Alrighty, well, sorry this video's been slow in coming out. Um, we were looking at functions. Now with these, I'm really not interested in doing a bunch of things with the turtles. So we'll look at some other examples. Um, but again, we just really want to look at this idea of defining the function with the DEF, and then the name, and then the parameters or inputs. Then you use a colon, and then the body uh, will be indented 4 spaces, and that's how it knows where the definite definition extends to. And then there's also the return statement, um, if you are returning uh, a um, value, I guess. And Okay, so let's look at those things. So again, this has a bunch of things with the turtles. You can look at those, you can try them, um, but I just think it throws some extra stuff in that we just really don't need to worry about. Okay, so yeah, as we know, functions typically require arguments, but they don't have to. Um, and in these cases, the variables that they get assigned are that go into them are called parameters. Now that's a little different in math because typically, if I say I have a function like a straight line function, f of x equals mx plus b, x we would tend to call the variable, and m and b, the slope and y-intercept, we would tend to call the parameters. So that's a little bit different than math in that the function arguments that go through, which is another name. So there are a few different names. You can call them the function variables. You can call them the arguments that get passed through, and and but they're also parameters. Okay, so um, uh, oh no, okay, I'm sorry. I said that, I stated that wrong. Parameters are once you're inside the function, so we'll look at that later. And then return values, and they call them fruitful functions. I had never heard that until this book. Fruitful functions, or a void function if it doesn't return anything. Okay, so let's look at some examples. We saw this example in class. Um, so if I just want to square a value, but I want to do it as a function, so I have this first line where I define the function, give it a name, and any arguments. Okay, and so then I do the square, and I return that value. Now, for whatever reason, I have return in parentheses, which you can do, but also I shouldn't have to as well, so I can do this as well. And so here I asked to input a number as a float, and then I square it. And so let's run this. Whoops. Oh, what did I do? Huh. I don't have parentheses around the print statement. That's funny. Whoops. Huh. I bet I got rid of, at some point here, got rid of the parentheses around the S instead of the Y when I was doing that. So input a number, And, you know, if I input a 5, hit enter, I get 25 out. You know, so that's your basic function. Now, for something more complicated, then you see here I have a parameter at this point. So I input the argument n, so there's an argument. But now f would be called a parameter because it's a variable that I assign inside of the function. And so here I'm doing a factorial. And a factorial, again, is if I, you know, wanted, well, I can type it in here. So if I wanted something like 4 factorial, that's defined as 4 times 3 times 2 times 1, and 0 factorial actually is defined as 1. It just makes life easier if you define 0 factorial as 1, but that is a true mathematical sort of definition. I mean, you know, when you look at our definition here, 4 times 3 times 2 times 1, you know, there's no reason why I should think 0 factorial should be 1, but it is. And so I define my factorial function. I started off as 1 because if I put in a 0, I would like it to return 1. And now if I put in negatives, you know, I think it'll still return 1, but we don't know how to handle error things like that. But you know, if it's any bigger than 0, you know, then it will go through this loop. You know, because if I have a range of 0, it doesn't do the loop. Okay, but if I have a range of 1 or more, it will do the loop, you know, that many times, 1 or 2 or 3. And so I just take f times I plus 1, because what I want is to take the current value of f, so the current factorial, and just multiply by the next number. But again, because things start at 0, that first time I come through here, I really want for n equal 1, you know, I will be equal to 0, so I need I times 1, or sorry, I plus 1 in order to make this work. And so we check with a factorial of 3, and here I print out the factorial inside the loop so you can see it being made, but then I also return f and then print out the factorial at the end. So if I run that, you see I got 1 at the first print, 2, and then 6, and the factorial is 6 because 3 times 2 times 1 is 6. Okay, so there's a factorial function that has a more complicated body or more complicated rules inside of it for the function. Now you can give multiple inputs to a function. So here I want to determine the slope for a pair of x and y's. So I've got x1, y1, x2, y2, and I just want to get the slope, which is y1 minus y2 over x1 minus x2. Again, if I put in a x1 that's equal to x2, I'll get an error, but we don't know how to handle that yet. So I just I define it, and then I return that value of m, the slope. Now we'll try to look at local values, but maybe we'll do that here. Is that this m defined inside the function does not change a value of m defined outside the function. Okay, so we'll see that we get the right answer here, but we'll try something to just see that we don't necessarily change the value here. So so we'll just run it once to see that this works. Okay, so there's minus 0.8. You can check the slope. You know, we have 3 minus 8, which is negative 0.5, and or negative 5, sorry, and 5 minus 1, which is 4, so we get negative 4 over 5, which is negative 0.8. Okay, just to see that the value doesn't get changed, let's do something like this. Let me just say m equals, say, 3. And then here I'm going to print, or not print, sorry, I'll just call this slope s. And then I'm going to print m and s. And I should get the value 3 and then the value minus 0.8. But you see, after I call slope, the value of m shouldn't get changed out here. It gets changed inside the slope definition, but not out here. And so you see I got 3 for m and minus 0.8 for s. So you see it didn't change. So when you define something locally like this, a parameter locally inside the function, it doesn't get changed. Okay. Now, oh, I didn't. So this is a function with multiple inputs and outputs. Okay, so here what I'm going to do is find the slope-intercept form of the line that goes through these points, and so I just add to that. So I find the slope, you know, using what I did to do the slope function, and then I calculate the intercept by taking that slope m times negative x1 plus y1. So I just, you know, used the point slope form and found b from that. And I could have used x2, y2 just as easily as x1, y1. So I do that. I use that same point, so I should get the same slope, but then I'll see what the intercept is. So run that, and the slope is 0.8, and the intercept, notice I say the y value of the intercept, because actually the y-intercept is a point. It's the point 0, comma, 7.4. And, you know, if I wanted to get fancy, I could do something like that with printing it out, but I didn't want to get too fancy. So I just said the y value of the intercept is 7.4. Okay. Then, finally, functions can call other functions. And since I've defined slope, the slope function, which I use here, already in a cell up here, up here, I don't have to redefine it in this cell, but I could. So I define a new function called perpendicular, where what I want to do is in that function, I want to take those same 4 points, or well, 4 values from 2 points, and what I'll do to get the slope perpendicular to the line joining those points is I'll calculate the slope, but hey, I've already done that work, and then I'll take -1 over its reciprocal. And, again, I have m's going all over the place here. I have the m from this slope, and now I still have the m from this that I used, but that'll get changed. Well, it actually already did get changed here, and then it will get changed again here when I use it there. So, and so here we get the slope of the perpendicular line. Now, so the reciprocal of -4/5 is +5/4, so I should get 1.25, and I run that, and I get 1.25. Let's see. One other thing, though, to show you is actually, I don't know what we'll define here. I hadn't really thought about doing this until just now. But there are global variables, and you can work with global variables in that you may have a variable that for whatever reason you don't want to pass it through the function definition, but you want the function to use it. Yeah, so, what might that be? Well, this would be very bad to do this, but suppose I define, I define a function called, now notice when I said eval, that turned green, so I don't want to call the function eval. There's already something in Python using those letters. So I'll say evaluate, and what I'll do is I'm just going to give it an x value to evaluate. And what I want to have it do is evaluate a line, just from a given line that I have. So I'm just going to return. I don't even have to assign it to anything. I'm going to return an m times x plus b. Well, of course, if I try to do this, that won't work because it has no idea what m and b are. So if I said here, like, evaluate two, and give it maybe f equals evaluate 2, and then I want to print it out. If I try to do this and I run it, that's funny. Okay, you may not think it's funny because you're saying I said it wasn't going to work. Well, yeah, it wasn't going to work, but I had m and b defined out here. Okay, so actually what were my last m and b? My last m was 1.25. My b was 7.4. I believe, right? Yeah, there's b. And so let's try that. Let me print, because I forgot about having done M and B up in these cells up here. But so let's print 1.25 times 2 plus 7.4. And you can probably do this in your head really fast and know that, yeah, we'll get 9.9. So yeah, that I was thinking it wouldn't work, so let's make it so it won't work. Let's, I don't think anywhere up here have I used an A, so I'll use an A here and a C. And now if I try to run this, I get an error. And it says name A is not defined. Now C isn't either, but that's the first one it came up to. And it's pointing out that, it first found it when it tried to evaluate, and then inside the evaluate function it found the A and the C. But so, here, well, order of course matters because, well, let's do this. So I'll say A equals 3 and B equals 6. And I try to run that. And again, though, you see it still doesn't know because I put those, I'll cut those and paste them here. And so they have to come before I evaluate because we have to know what they are as they run. And, oh, I said B, not C, sorry. Run, and there we get 12. And if I tried that same thing here, my 3 and my 6, I should get 12. And so, there I made these global, they were outside. Now there are times when I have felt I had to do that, but generally speaking, that's a bad idea. You probably don't want to do it that way. So I'll call that done.